I'd say have at it. This session is about to start.
Okay. All right.
What's new SQL? And here's Jeff McMahon to present.
All right. So, yeah. So my name is Jeff McMahon. I've been with Informix since about 1995, and I've spent about a decade or so in support, and then I've been in development ever since. And so a lot of the stuff I do is in the what we call the SQL group. So I'm basically presenting many of the features that I've done over the last several years and some of the new ones that we're working on. And a lot of these slides, if you've been to previous IIUGs or listened to any of my previous presentations, might be redundant for you, but I thought I would go ahead and include them all in case there are some folks that have not seen them all. So I'll get started off here. Each of the slides I put in the upper right-hand corner which versions of Informix that these features are in. So some of this overlaps back into the later 12.10 days. And then once 14.10 became the new version, some of them are exclusively in 14.10. So each one of those slides will have it in the upper right-hand corner. So the first one is no validate for check constraints. Way back when, there was a request that when we added foreign keys, we wanted the ability to avoid the checking phase, which could take a long time on a large table. So there was framework already in the product for that kind of thing. And so eventually customers asked for the ability to do the same thing with check constraints. So, you know, if you added a constraint, a check constraint, it would go validate all the data. And so now if you want to forego that step, you can use the no validate option. And of course, the risk you take with doing that is you've now accepted responsibility that all the data is valid and correct. So that's 12.10 FC7, 14.10 FC1. The next one was one that was kind of a pet peeve of mine for maybe 20 years, where these system named indexes, when you created constraints like primary keys and foreign keys, the system would create an index for you if you didn't have an index already there. So they had these names that started out with a space followed by a number, and you couldn't rename them. And they're kind of system generated numbers that don't mean a whole lot. So for many years, it's just kind of hard to diagnose things and monitor things when they're unfamiliar names. So we added in the ability to just rename them. It's kind of a simple code change, and turned out to be something that a lot of people had asked for many years. So that was a pretty good one to make your database a little more friendly. And that was 12.10 FC8 and 14.10 FC1. And so in the same spirit of system generated cryptic names, we also had constraints that had a similar naming convention. There was a letter in front of these numbers this time. So the number that you see there is the tab ID, which would only be meaningful if you've looked at sys tables to see what your tab ID is. But these had like a U for unique, R for referential, N for not null, and C for check constraint. And of course, in all four of those cases, it would be nice to have something that was a little bit more meaningful, that maybe had your table name in it and had maybe you know, the type of constraint that it is. So starting with those two versions, you could now just rename them with a SQL statement that was instantaneous. Okay, this next one, truncate table, keep statistics. So, you know, truncate table exists. You can just blow away all the data in one quick command that is very quick. But there was a request that came in from some customers that every time we truncate the table, it also zaps the statistics. So now any queries that are generating query plans think the table is empty. and we'll do a sequential scan on the table. But if that table quickly grows within a matter of seconds or minutes and becomes big enough that a sequential scan is not good, now you've got to run update statistics on the table again, and then run your query again to get the proper query plan. So the request was, let's just keep the statistics that we had when the table was full, knowing that we're going to be truncating this thing regularly. Let's just keep the statistics perpetual, basically some stale statistics, so to speak. So this option here was just keep statistics. So if you had a desire to have such a table in your system and wanted to use this, you could do that. And so it'll just keep, in what are the system catalogs like sys indices and those that keep the statistics, it would just keep them there and let them live on for the next truncate.
Hey, Jeff, I have a question in the chat.
Yeah.
How about truncate table with replication? Useful in ER world, according to Paul Watson.
Okay, that sounds like a feature request. Yeah, okay. Let me make a note of that. So Paul, probably the best thing to do is to put a request in the AHA system so it's official and in the queue, but I can make a note of that as well. Okay. Okay, so moving along a little bit more current, 1210 FC12 and 1410 FC1. So some of the alter tables that were slow alters were needed to be in-place alters, because the slow alters take forever if the table is large. And some of these, I'm remembering back when we implemented this, there was just no good reason that we could find that they were ever designed to be slow alters. So, going from a character to a varchar didn't make any sense that had to be a slow alter. It should have just been an in-place alter. Same with varchar, making it smaller or larger. And then there was this other strange criteria that was in the code, that if another column in the table was either a Boolean or an lvarchar, it just disallowed this operation completely. And so after some investigation, we just determined that, whoever wrote the code at that time just decided to make it that way. And so it was just a fairly trivial thing to just loosen those restrictions. And so now we have in-place alters for these operations, which of course, you don't have to take an outage now to make these schema changes in the tables. And while doing that same work, the next slide here is, why do we need to rebuild indexes when we're doing some of these operations? And of course, the bigger the table, the longer it takes to rebuild your index. So these are now situations where you don't have to have the index rebuilt. So if you're taking a varchar and going larger or smaller, it's okay. It won't rebuild the index. But there is a scenario where the index will be rebuilt. And if you go, let's see if I can remember this correctly. It was, okay, I think it's that bottom one that I was coming to. If you go smaller and then larger, it will actually rebuild the index. And there was some strange reason for that. And also if there's a composite index too, that also applies. Another one that we looked at in that same time frame was going from numeric to serial. So a lot of these requests came in to change integer columns or big ints or even int 8s to serial types. And that's also something that's now in place alter, whereas before it was a slow alter. So those three last slides are basically just things that caused us to look at the code a little bit more. Why were they created as slow alters in the first place? And after some discussions and investigation, came to realize that there was no reason to keep them as slow alters. So they were, we basically freed them all up to be in place. Okay. Oh, this slide just came here. Okay, so here's another one where the request came in to alter a primary key column, but we want to keep the check constraints and the foreign key constraints or not. And so let me just make sure I'm on the right slide here. Sorry, guys. Yeah, okay. So this was a scenario where a primary table, the primary key table had something like 250 child tables. And so if you're going to go in and alter your primary key column to say an integer to a big integer, it would require dropping all 250 foreign keys, and which if you had system named indexes underneath those foreign keys would also drop the indexes. So you would want to go back to my slide number 2 back there and rename the indexes to be something other than system generated so you could avoid that step. But even so, you would have to go drop all the foreign keys, alter the tables of all 250 child tables to also go from int to big int, and then recreate all of your foreign keys with the new primary key. So quite a big operation if you have a large system with a parent table with, in this case, hundreds of foreign keys. And so the request was, can't we just maybe pick and choose some of the foreign keys that we're going to change at that time, or even none of them? If we're going to go ahead and change the primary table from int to big int, who cares if all the child tables are still int, as long as we don't have any values in the parent that go beyond the 4-byte integer. There's no need to change these things. So we could basically do it when we wanted to do it. And so, maybe all these foreign key tables aren't even going to have any concern with the values that are going into the parent table until a later time. So here's where we came up with this. Of course, it's a bit of a crazy syntax, but we had to cover all bases here. So you could, you basically could keep any of the foreign keys, or you could keep any of the check constraints, or you could drop them. The default behavior is to drop them. But if you keep them, then at some point you've got to go back and drop and recreate them, as you get to the point where you're getting that 4-byte integer in the primary table that's going to go beyond the 4-byte limitation. So you're kind of just kicking the can down the road, but that's okay if you're understanding the scenario that you're facing. Okay.
I figured I'd break in since you actually took a minute to take a breath. There are 2 questions in the chat. FYI, all you guys out there, Jeff can't see the chat, so that's why I'm having to read it to him.
Ah, yeah.
So one question is, since you've got int to big serial, is there also int to big int fast?
Yes, yes. In fact, that is, let me go back there. Yep. Those are all in place alters as well. So int to big int, even, I'm afraid to even say this, but even if you went int to int 8, that is also an in place alter as well. But we kind of frown upon the int 8 because it's, well, one of those things we'd like to deprecate, but we can't because it still is required. But int 8 actually takes up more storage than a big int, and it has more overhead than a big int. But yes, you could go int to big int. In fact, you can even do small int to int and small int to big int. Those are all in place alters as well.
And then one more regarding char, varchar, lvarchar. Will you talk about char length semantic support for UTF-8 encoding?
Yikes.
Yeah, and just say no if it's not where you want to go. I'm just reading it off the chat.
I honestly know very little about UTF encoding, so I'll have to defer that to somebody who does know that. So,
Good enough. All right, that's it for me.
okay, cool. All right, so the next one is create or replace procedure. And this is one so you don't have to drop. So if you want to change your store procedure, you don't have to now drop it and recreate it. And I think a lot of the other databases out there have such an option here where you can just replace it. So, you know, if the store procedure does not exist, it'll create it. And if the store procedure does exist, it'll just do an in-place update to it. So it'll purge the entries out of sysproc-plan and sysprocedures and put the new ones into sysproc-plan. And well, it doesn't remove it from sysprocedures, but it'll just connect the new entry in sysproc-plan with the existing entry in sysprocedures. So just a little bit quicker way to update your store procedures if you don't want to drop and recreate. Okay, partial index is this is one that came in that where there is a huge skew on the data, and I think the use case was null and not null data, or maybe it was binary where most of the entries are like a value of 1 and very few entries are a value of 0. So we wanted to create an index. And so the idea here was we don't want to have a big B tree on this part of the table that we're not concerned about. And so what we did is created this fragment by expression, and we could use this index off syntax. And so basically there's no index on this part of the data that you've declared. So I guess what we've used here in the slide is the customer table with zip code. So that's probably a bad example because there's only one state of Arizona and one state of California. But if we had, you know, value is greater than 0 and value is less than 0, and 99% of your data is greater than 0, you know, you might want an index for that, or and you might not want the index for the smaller piece, or vice versa. You know, if we're never even going to query the larger piece, maybe we want the index off for that one as well. So it gives you the flexibility to pick and choose which parts you want the index on and which you don't. Okay, so this is the query plans and the statement cache. So a lot of the questions were, you know, so if you've enabled your statement cache and you're running at a steady state and all of a sudden something goes wrong, and this is back to my support days where something would happen to the statement cache. It might just be one particular query that has changed its query plan, and that's, you know, wreaking havoc on the whole system because it's an aggressively used query. It went from an index lookup to a sequential scan, and now all of a sudden all the CPUs are pegged out, and what's going on here? There's no good way to figure out what in the statement cache is actually the problem. And so the solution would be you either bounce your instance or you run this onmode-e option to, you know, basically purge the statement cache. And now the statement cache has to, you know, rebuild every query. So the first thing that we wanted to do is expose the query plan. So there's now a new onConfig parameter, statement cache query plan, that will actually store the ASCII text of the query plan that is stored in the statement cache for that query. So I'll show you on the next slide where you can look at that. It's disabled by default, and the reason that is because there's a statement cache heap size that's declared in your onConfig file, and if you enable this, it's going to use up more of that memory, and now you've got a pay attention to how much memory the statement cache is using, because it's going to consume more. And so, last thing we want to do is have something like that happen. So if you want to use this, you can. You just have to enable it. And that led to a new sysmaster table that you can use called, I guess we've called it syssscelem. Not exactly a very descriptive name, but that's what it's called. And so it's basically the same thing that you see if you run onstat-g ssc. You get that large amount of output that shows, well, the columns that you see here, but it shows the query, which can be very large if you've got a huge query there. And so the output's, I don't know, cosmetically a little bit challenging sometimes. So the sysmaster table gives you the same thing. So now you can use things like trim and concatenate and stuff like that if you want to make it look more cosmetically viewable. But there's three extra columns that are here that you're not going to see in the onstat output. One is this valid column that I'll talk about in a couple slides. One of them is a locked column that I'll also talk about. But the one we're talking about here is query plan. So I'll jump to the next slide here. And so you basically just see exactly what you would see in sqexplain.out. And so when I was doing this work, I basically consolidated. So the existing code that printed to sqexplain.out was basically to a file. And so I just merged in, let's put it in a buffer, use the same exact code. So it's at runtime inside of our server, it's the exact same code that you would see in sqexplain.out, but instead of going to a file descriptor, we just go to a buffer character pointer. So you'll see no difference whatsoever between your file and what you see when you look at the query plan that's in memory. Okay. Let's see here. So back in the topic of the statement cache, where we have this query that goes to an undesirable query plan, the first thing was I want to be able to see the query plan so I can figure out which one's bad. And so that's what that sysmaster table gives the ability to do. But then the next thing was, once I find the bad query plan, is there any way I can just disable that one query? Can I just selectively decide which of the statements in the cache that I don't like, so I don't have to purge the entire cache and let the whole cache rebuild? And so using that same table, this is one of the sysmaster tables that's actually updatable. There's actually a couple of them that are updatable, but this is one. Most of them are just read only. So this one here, we can, and this is the reason I added this valid column. So if we want to make that particular query invalid, we can just update it to be 0. So basically precision here to decide which ones you want to invalidate. And so when you run onstat-g ssc, there's a D flag that if you've used the statement cache in the past on your system and looked at onstat-g ssc, you might find one that's been invalidated. You would see a D flag, which I think means marked for delete. So if it hits some high water mark, it'll actually flush this one out of the cache. And then also, if you prefer to use sysmaster, now we see that the valid flag is going to be 0. So some of the feedback I've gotten is that's, I don't know, too precise, and some of the feedback is this is exactly what I needed to invalidate that one query that's causing all the problems. So okay, and another thing is locking the query plan. So I guess the theme here is, the first thing is I want to see the query plan. Then I want to disable the one query that's gone bad. But the third thing that was requested is I want to be able to lock it in. Let's just prevent all of this in the first place. So and what was causing these kinds of things that I was dealing with the customers that were coming my way with this is the, update statistics. So when you run update statistics, you probably, I'm guessing most people have had some experience where a query or more has, I don't know, gone to a less desirable query plan after update statistics is run. And so that's where, optimizer directives are nice. You can kind of lock it in. So the same thing is applied here. I basically this is kind of like an optimizer directive. I want to lock it in. So now you can use this locked column that's in the sysmaster table to lock in your query plan. So now anytime update statistics is run, it's going to leave these alone. These are forever going to be locked with the query plan that they're running at that time. And it's all based on the minor version of the table. So in Informix, we have what we call a major version and a minor version. And update statistics is one of those that updates the minor version. So it's not a huge, it's not a table schema change. It's just something like statistics has changed. So we're going to ignore those. Those are locked in. We don't care about the minor version change. But if you do something like add a column to your table, that's a major version change. And that will, the locked protection doesn't keep you from locking the plan in for that. That's going to have to be rebuilt. So those types of entries will get purged and rebuilt at a later time. Okay, so they can be locked and unlocked at any time. And here's the onstat version of seeing that capital L flag there at the bottom, declaring that it's been locked. And you can also use the sysmaster table to view it also. So in this case, we have a valid one, it's locked. And if you just leave it like that forever and run update statistics all you like, it's always going to be that plan. Okay. So now we're getting even more current, 1410 FC4. This is one of those things I was looking at. We must have had somebody else doing the user interface for these on mode options, because well, I guess you're all familiar with all the onstat and on mode options. Like 90% of them follow a known definition, but these were a little bit different. So there's this on mode E, and then there's on, off, enable, and flush to decide which of those activities you want to do with your statement cache. And then there's an on mode capital W, that if you want to change your no limit or your number of hits, there was a little bit different syntax for that one too. So these two have a little bit different syntax than other on mode options. And you could also do the same things with the sysadmin API. So you could do, execute function task on mode E enable, and like you see there on the slides. And so decided let's make this a little more intuitive. So all those old ones are still supported, but we added these new ones in that are a little bit more intuitive. So if you want to, enable your cache or flush it, you can do statement cache enable, statement cache flush, which I think as I go back just looks nicer than, quote on mode, quote E, quote enable. It just, this just seems a little bit more user friendly. And so what led me to do that stuff is what I'm going to show you in this next slide here. Is another feature was to save the cache and restore the cache. So having all these abilities to view the query plan and lock in the plans and validate the, the entries and things like that, eventually you're going to get to some steady state where you like what's in the cache, your system's running at optimal performance. You want to save that cache to disk in case sometime you want to restore it. So if you save it off and something goes wrong, or even if you bounce your instance, you can bring it back up and then restore the cache with the exact same information that was in the cache when you saved it. So that led to this new one, execute function task statement cache save. And so What it does is it creates a table in the sysadmin database called statement cache, and it creates a table and it locks the current cache, and all the valid cache statements will be saved into that table. And if the statement is locked, the linearized query plan will also be saved, which is the binary query plan that's in the cache that you can't read, because that's what that query plan text on config parameter does. So if you want to actually view what's in it, then you have to enable that on config parameter. So if you don't have the query plan on config parameter enabled, we still store the binary version of the query plan, because that's what we would restore into memory if we ever decide to restore the cache. But if you also have that on config parameter enabled, we'll store the text as well. So that'll be viewable through sysmaster if you restore it as well. And after all that's done, then we unlock the statement cache. And then you can go look at this table, this sysadmin statement cache table. It's on disk, it's viewable, and you can see what we've actually stored in there. So on the flip side of that, we can restore it. So if we decide we want to restore it, it's going to lock the current cache and it's going to flush it. It's going to purge it. And it's basically just going to walk through that table that we have on disk and put everything back into memory as it was when we flushed it, when we saved it. So, and likewise, if that statement cache query plan setting was set to 1 and we stored all of those ASCII representations of the query plans, those are also going to be put back into the current cache when we restore it. So I guess in a nutshell, it's going to take whatever's in memory, stick it on disk, and whatever's on disk, it's going to put it back into memory. So I don't know if anybody on this call has used these features or not, but I'd be interested to hear any feedback if you've used any of this stuff and see how good or bad. Okay, moving on here to the next one. So another 1410 FC4 feature in SPL, there was a request to have a returning clause that used like table.column. Informix already supported defines that are like table.column and already supported parameter lists, parameters that were like table.column, but we didn't support returning table like table.column. And that's another one that I kind of scratch my head. It's like whoever did this code originally, well, they covered 2 out of the 3, but didn't do the last one. So the work was kind of easy for me to do this because, you know, the foundation was already there. I just had to piggyback on the exact same thing that was already done for the 2 other cases. So now we've got that ability as well. So the nice thing is if you go and do these column changes in your table, you don't have to update your store procedure because it's going to automatically inherit whatever that new column is like. Whereas before, if you had returning integer and now it's going to return a big int, well, now you've got to go recreate your store procedure and change the syntax and replace it or drop and recreate it. So this is just less maintenance, less overhead when you do table schema changes that you don't have to go in and change your store procedures. Okay, another one, the last access time for a store procedure. This is one that, all the onstats that Informix has, there's usually some sort of a timestamp in there that people look at and, makes it useful to see the last time it was used or maybe when it was created, etc. And so, but store procedures, it's, there was never a timestamp there. So this is just a simple addition to onstat G PRC. Just gives the last access time that store procedure was executed. So might be useful if you're looking to maybe deprecate some store procedures or, see how often they're run. So this kind of thing can be useful there. Later on, which I'll just move to the next slide here, 1410 FC6, we added it to sysmaster, which I think was the original request is to have it in sysmaster, but the framework wasn't in place to do sysmaster updates. But the good news is starting with 1410 FC6 and going forward, we can change sysmaster every version. There's an automatic rebuild now that's in place going forward. So if you're ever making requests for sysmaster changes, and in the past have had to wait, several versions to have those actually implemented, we don't have that restriction now. So we can make the changes version to version much quicker. Okay. This request came in. I think this is one I remember back even in my tech support days, but who's using all the temp space? Which queries are hogging up all the temp spaces? And I think there were clever ways to figure that out, through some of the onstats and maybe even look at oncheck PE and things like that. But that's takes a little bit of work and it's not quite so intuitive. So a few versions back, there were some changes that were done in the server where you could create this very elaborate sysmaster query and go fish this information out, but it involved a bunch of table joins and knowing certain flags and things like that. So all this is it's just a view. It's in sysmaster.sql, sys session temp space usage, that you can just run that directly to figure out where the temp space is being used, how many pages, and it'll show all, things like hash joins. Trying to think, anything that uses temp space will be shown here. So all explicit ones, which could be create temp table, insert into temp, or select into temp, or big elaborate queries that are creating system generated temp tables. Those will also be reported there as well. I have to believe that probably everyone on this call has a use for this, because I know it's who's using the temp space has probably been a persistent question for my entire career with Informix. So hopefully that's useful to everyone. Okay, so here's a couple of the things that we're working on now. Data dictionary performance improvements is one that I'm working on as we speak. And this is, I'm just guessing that everyone has at least seen this DDH chain mutex weight on their system at some point. And historically, there's the DD hash size and the DD hash max on config parameters. And there's been some kind of a voodoo formula that one of them needs to be a prime number and the other one needs to be, something strategic to try to get the most number of hash lists as possible with the least number of entries per hash list to get the best amount of performance. And that's one of those things that's kind of, try it and see. And if it doesn't work, try a different number and see. And it's kind of a non-intuitive way to try to tune the optimal size of your dictionary cache. And even if you give it a lot of effort and come up with something good, maybe one hash list has 20 entries in it and all the rest of them have one. So there's no absolute way to just make it perfect. And even in the best case scenario, if you have one entry in one of the hash lists and that table happens to be the busiest table on the system, you still might see this mutex weight DDH chain. So, I know probably even as far back as 15 years ago or so, I know I've, even in my support days, seen this type of mutex DDH chain. And many times it's not a big deal. It's just there's hundreds, if not thousands, of spin locks and mutexes in Informix, and you're bound to see some of them at some point in time. It's not necessarily a problem. It's just a synchronization of something that's taken place in the database. But if you see something persistent like this, and you happen to see, like onstat glmx, and you see wait times that are 2, 3, 4, 5, 10 seconds or whatever, now you've got something that's of concern. And so the work that I'm doing now on this is to change the type of mutex that it is. And right now it's just one of those, it's an exclusive mutex. It's going to be changed to what we call a read-write mutex. So you can have, thousands of threads accessing it in parallel if the only purpose is to increment and decrement the ref count, which is like 99% of the work that's needed for these entries.
Jeff, here's your 9-minute warning.
Okay. Wow, that went fast. Thank you.
Yep.
Okay. Okay, so I guess to summarize this slide, then this should be one of those free performance increases that, maybe you don't even know if you've got mutex contention on your system because you've just never even looked for it. And so when this is released, you'll just get a free performance boost that you didn't even know was there. So, and then so for the folks that are actually in tune to this kind of thing, then you'll know that there's some relief coming for this. And I've got 2 last slides then. This is this is something that we're looking at right now. A request had come in to basically make indexes invisible to queries, but keep the index maintained. So maybe there's a whole bunch of indexes in your system that you don't even know if they're being used or not. And if they're, you don't know if they're being used for queries. They're being used for updates and inserts and deletes because that has to be maintained. But if you want to just make it invisible for queries and none of the queries suffer from not having that index viewable, then maybe you can just drop your index and get rid of it and free up the space. So that's one of the requests that's come in that we're looking at now. And the final one that I'll just talk about is obtaining the query plan of a running query. So this is kind of like the statement cache one with the being able to view the query plan of the queries that are in the statement cache. There's also a request to be able to view the query plan of any running query in the system. So that's also another one that's in the queue that's being evaluated. And I think that's my last, that's my last slide. I feel like that went by like in 5 minutes, and I feel like I talked really fast, but are there any other questions?
Do you want to make your chat visible to you? We don't need your PowerPoint there if you
Oh, yep. Okay, how do I do that?
that way you can read it rather than having me read it.
If I can figure out how to do it. I still see users. Let's see here. Oh, here we go. Drop down, stop sharing. Hey, I did it. Okay. Okay. So the UTF-8. So login is also used. Well, I appreciate the feedback and the comments. I don't see any questions though, per se. And I'm sorry, I don't know the UTF-8 answer. That's the one I don't have a good answer for that one.
There's one there. Statement cache save restore, and then.
Oh yeah, could it be part of a shutdown? Yeah, absolutely. It that would have to be probably something in the well, I'm thinking two answers to that question is one is I think you can add like a sysadmin task that during shutdown does certain things and startup that does certain things that could be added manually. But that sounds like a good feature to add to the product, just to have it done by default. There could be like a template task in there that's either enabled or disabled by default that can just be flipped on or off to be part of that, to make it automatic. So yeah, that's a good idea. Something to add to the mix.
Anything
All
else?
right.
Chat will be saved. The session's recorded, and I believe the chat is saved as well. If there's something in there that I didn't catch and you didn't catch,
Okay.
it should be saved in theory.
Sounds good. All right. Well, thank you everyone for attending.
All right. Thanks, y'all. Thanks, Jeff.
Thanks. Bye-bye.
We'll be back at 2:10 Eastern.